Alrighty, hi everybody, welcome. Today we have with us Professor Simmons, who is the director of the AI program here at CMU and also a research professor in the Robotics Institute with a special interest in autonomous systems and human-robot interaction. Welcome, Professor Simmons.
Thanks very much for taking the time to talk with me.
What sparked your interest and passion for AI research?
Actually, I think I started being interested in high school, which I guess I'm not too ashamed to admit was in the early 1970s. So it's been 50 years. But at that time, I didn't really know that there was a field called artificial intelligence. I was just playing around with computer programs to play games. And then when I got to university in my junior year, they hired a new faculty member who was he had done his degree in artificial intelligence, and I'd been doing work in computer graphics, researching computer graphics, but this just caught my attention. Took his course, did research with him, and kind of never looked back. I was just fascinated with the idea that computer programs could emulate human intelligence. That was 40 years ago, and we're still working on the problem. I have to tell you an anecdote that when I got to graduate school in 1980, I was worried that by the time I graduated with my PhD, that the field would be over with, and that there would be nothing for me to do for the rest of my career in that area. And fortunately, I was quite wrong about that. And even with the increase in interest in the capabilities of these large language models, there's still a long way to go.
Mm-hmm. Yeah, for sure. What would you say are some of the most memorable areas of research or projects that you've worked on in your career?
Good question. So I started out doing a lot of work with NASA. One of the most memorable things about that was I was involved with a project that a software project that actually flew in space and helped control a spacecraft autonomously for a few days. That was really exciting to be involved in something that momentous, and software that we'd worked on to drive rovers, Mars rovers, eventually was adapted by NASA, and the grandchildren of that software package are now running around on Mars, driving the rover autonomously. So those were kind of two of the early highlights. But the reason I got into human-robot interaction is that I was doing research in autonomous robot navigation, and we were trying out a new algorithm by running it around Wien Hall for months at a time. While we were observing how the robot was doing, we also were noticing how people would interact with the robot, and they would interact with the robot in very different ways than they would interact with people. There was kind of three categories of people. One, which was relatively small, was the people who were nonchalant. They just did treat the robot like anything in the environment. But the majority of people were what I call wall huggers. They would see the robot coming around. They had either heard about it or interacted with it and realized it was not going to operate like a human, and so they would just give it, move off to the side, let the robot go on, and then they'd move forward. And then there were the robotics students who would jump in front of the robot and try and break it and see if it would run them over. But it was the wall huggers that really caught our attention. That was like, okay, well, if we want to have robots in the world, interact with people, the robot should adapt to the people rather than the people adapting to the robot. Mm-hmm. And that's like different than any technology that we have. I mean, most technologies we have, people have to adapt to the interface of the technology, whether it's a smartphone or a TV or a microwave or anything like that. And I really believe that the future is where machines will interact with us as more naturally as people interact with each other, rather than us interacting with machines like they're machines.
Mm-hmm. Awesome. And so I hear that you're also part of the AI Caring Institute. Could you maybe tell us a little bit more about your work there and also what got you interested in working in that area?
Let's see. So the AI Caring Institute is developing AI technologies to help older adults live independently for longer. The population is aging. It's really important for people to maintain. I've seen my own parents and my in-laws, getting to the point where they needed to be, sent to an institution because they couldn't take care of themselves. And in some of those cases, it was disease that they needed to, but in several of the other cases, it was that they were living alone and they didn't have that type of support that could have kept them going. I mean, like my mother-in-law at one point, left the stove on, nearly burned down the kitchen. Those are the types of things that it would be great to have technology that could just notice what they were doing, realize, hey, they're no longer cooking, but the stove's still on, and warn them, or call a neighbor to have them come in and take a look at what's going on. So I think that type of technology is really important. My own personal interest in that is in personalization, and I think that for the last maybe 7 or 8 years, this has kind of been the focus of my HRI research, which is trying to push the idea that technology is not one size fits all, and that personalizing the technology, the way it interacts with people to their particular personality, their particular needs, is incredibly important. And so we're using a lot of machine learning techniques to, including large language models, to understand, to try and learn people's personal preferences and then interact with them differently based on what their preferences are.
What is something unexpected that happened during your career that you're glad happened?
When I graduated my PhD, I was looking for a job, and I interviewed at a university, not Carnegie Mellon, I interviewed at a university that I really thought I wanted to go to. And the university had difficulty getting their act together to make me an offer. And during that time, I got a call from Carnegie Mellon asking if I would be interested in coming as a postdoc to work on a robotic project, a Mars rover project, and being the AI person involved in that. I really was not interested in coming to Pittsburgh, I have to be honest with you. But the Carnegie Mellon offer, I had to make a decision, and the day after I accepted to come to Carnegie Mellon, the other university came through with their offer, and it was like, it's too late. And I was disappointed at the time, but I am so grateful that I came here, because I've had offers to go elsewhere. I've turned them all down. This is, to me, the very best place to do artificial intelligence and robotics in the world. And so I'm very glad that happened.
I mean, we're also very grateful, because I don't think I would be here without the AI program that you have spearheaded either. What advice you would give to a CMU student who is interested in AI and AI research and would like to explore more about the field?
Classwork is important. Classrooms are important, but the way you really get involved is by doing. And a lot of people, freshmen will come and say, I want to get involved in research, but I don't have the knowledge to really. And I'm like, just get involved in something. When you start and you're adjacent to the PhD students who are working, and the postdocs who are working on the problems, you get to learn an awful lot. And even if you might not initially be doing like groundbreaking research, it's important to actually do things. And so even if there are things like, it's like, well, this isn't really what I want to do, as a start, almost all the undergraduates who work for me, started that way, and eventually, got to the point where they were able to do more fundamental research. The other way is talk to professors that you you have a bond with through class, and that you enjoyed the class, you enjoyed listening to them, learning from them, and see what they have to offer, possibilities they have to offer. A lot of professors are really open to having people work with them, but they don't necessarily publicize that. So that's a good way to get involved.
How do you see the kind of future forecast of how AI is going to be used in our everyday lives? Do you see a major focus on the generation aspect, or do you think that's going to die down a little bit?
So that's a great question. I have kind of two responses to that. One is that we do have a lot of tools that have been developed that can do things like planning and reasoning, search, very simple things that people are trying to replicate in foundational models. And to me, that doesn't make a lot of sense, right? It's like trying to shoehorn something that we already know pretty well how to do into something that wasn't actually developed for that. So, I mean, the way transformer architectures work is they're predicting the next token at a time. That is contrary to the way we do planning, because planning is looking ahead, not just at the next thing. So you could kind of shoehorn it in, but I think the benefits that a lot of people are starting to look at is how to combine what we already know how to do with these generative models to get the best of both worlds. So that's part of the answer. I think that the future is not large language models and nothing else. It's taking this generative AI for what it can do well and pairing it with things that, as I said, we already know how to do. The other part of the answer is, the industry and government is putting billions of dollars into AI. Is it going to peter out like in previous AI winters? I think the answer is no. I think that in previous times, AI was hot in industry, but it didn't reach the general population. Nowadays, it reaches everybody. From personal assistants, speech recognition, self-driving cars. All these things are things that people see on a near daily basis. And I love this quote from Andrew Ng, who's a prominent machine learning researcher. He said that AI is the new electricity. And I really believe that just like electricity, started out, it was only in a few houses, and it had a long, they couldn't transmit electricity over long distances without some breakthroughs. But nowadays it's ubiquitous, and we don't even think about electricity. And AI is going to be the same way. It's just like everything is going to have some aspect of AI in it, making it better, personalizing it to us. So I think that we're over that hump. Do I think that transformer architectures is the pinnacle? No. And even people who have worked on transformer architectures don't believe that it's the pinnacle. That we need things that are less energy intensive in order to generate the models, even more flexible, and I think that is something that's going to come along, and just like the transformer architectures basically took over from things like LSTMs. The next generation of architecture is going to have a similar quantum leap and move us forward.
Yeah, thank you so much for that response. I feel like it's really insightful to kind of see the difference between like a research perspective versus just an industry perspective. But yes, thank you so much for your time. We've really enjoyed your insight, and yeah, thanks.